Hello class, Billy Mays here, and today we're doing graphing absolute value functions 3.7.
All right, thank you.
Thank you, Billy.
Okay. Can somebody remind me what is the symbol for absolute value? What does it look like?
An arrow. Are you talking about the bars? Absolute
The bars,
value?
exactly.
They look like straight and parentheses.
Yeah, they're bars. Okay. So what we're gonna look at today is we're gonna look at equations, but the equation is gonna have those bars in it. We've never drawn one like that before. Okay, we've drawn equations without bars, like y equals mx plus b. Today we're gonna look at ones that have bars. Okay, so how do you know if what you're looking at is an absolute value function? Well, basically, if it has the bars in it. Okay? If it has the bars in it, that's called an absolute value expression. So we're going to look at absolute values that, I'll come right back. Let me show you an example. Like that. Okay? That's not as simple as it could be because there's a plus 3. There's a minus 1. Okay? This one has a couple things, a plus 2 and a minus 4. If we wanted to simplify that and make it... Question. Hold on one second. Savannah, what's your question? We're going to go right back. Yep. So if you wanted to make this absolute value as simple as possible, you would get rid of all the numbers. And all you would write is that. Okay, the simplest absolute value function is that. Y equals absolute value of x. You can't get any simpler than that. There's no numbers, there's no plus sign, there's no minus sign. That's as simple as it gets. And because that's the simplest one, and every other absolute value function comes from that one, they call that the parent function. Okay? Anything you do to change that, it's no longer the parent function. The parent function is the simplest one. Everything else comes from that. That's why they call it parent function. Now, when we draw an absolute value, we've got a couple things we never had before. Okay? First of all, just to show you the graph, it looks like a V shape. Okay? When we draw an absolute value picture, it is a V shape. How narrow is the V or how wide is it? Depends on the problem. The bottom of that V, right where that arrow is pointing, that's called the vertex. So the goal with an absolute value function is you have to figure out where that vertex is. And then from there, you draw the V. Okay, but you got to find where the point of the V first. Okay, so notice the graph is going down. It hits that vertex, and then it changes direction. Okay, so it's going down, and it goes the other way. Domain. Can someone remind me, what letter does domain have to do with?
It's X.
X.
Yeah, it is.
Domain is X.
Oh yeah.
Okay, look at that V shape in blue. How far does that go to the left and the right?
Infinity.
Right. Forever. Okay? It's going to go to the left forever. It's going to go to the right forever. How do we write that? Does anybody remember when you write all the numbers?
Y equals mx plus b? No. Sorry.
It's okay, Josh.
How do we describe, it's 3 words. How do you describe the domain? How do you describe the domain, Josiah?
Domain, it just goes on.
So do you remember the words you used to describe it?
Infinite.
Okay, close, not infinite.
Infinity.
So usually we say
Never ending.
never ending. What kinds of numbers is it? How many of them? A lot. It's
More than infinity.
All blank blank.
All real numbers.
More than pi.
all real numbers.
Oh yeah, I learned from
How can they be fake?
Then I didn't do anything.
Good question. What's a real number? What does that word even mean?
Like whole numbers,
It includes positives. What else does it include?
whole numbers.
Whole numbers,
Even numbers.
No.
negatives.
That's racist.
What other kind of numbers? Positives, negatives.
Whole.
What other kind of numbers can you have? Like someone said whole numbers,
Fraction.
fractions. Yep.
Very nice.
Decimals.
Decimal numbers.
So when we say real number, Fred, real number means anything. Positive, negative, fraction, decimal.
I thought you can't have negative.
0. Now the range.
So if domain deals with the x, right, guys, what does range deal with?
The range.
Domain deals with the x. What does
Y.
y? Right,
So I
good.
just got my answers myself.
Now, look at that. Does that V shape go up and down forever?
No.
No. Which way does it go?
Right.
Nowhere.
It goes down and then-
It goes.
Up. Around.
Does it go? Well, we said it doesn't go up and
It
down.
goes up
It
forever.
goes.
It goes up forever. What's the lowest that it ever goes?
Zero.
All that.
0. So the range, the way we write the range,
Thanks.
the range goes from 0, how high?
To infinity.
To infinity.
What's that mean?
Infinity.
That's right.
That means infinity.
Does anybody remember what that's called?
Sideways here, yeah.
We did these before.
Greater than or equal to?
Yeah, inequality, right?
Oh,
It's
the
a,
inequality.
it's a compound inequality. Remember we said we did those before? So this is saying that y is greater than or equal to 0 and less than infinity. So with an absolute value graph, domain is always negative infinity to infinity, never changes. Range depends on the problem. Usually it has a low point, and then from that low point it goes up forever.
Say, we do sort of open down as well.
I'm not sure if we have one. Maybe we could. Yeah.
But guys, it's always going to open either, the graph's always going to open either up or open down. It's never going to open like sideways or anything.
Right. So when we say it's a V shape, it could be a V shape that's upward,
Yeah,
or it could be
Upside down.
Upside down.
could be upside down. And the vertex doesn't always have to be right there.
That could shift.
What is that point called?
The origin.
The origin, right? For the parent function, the one that's as basic as you can get, there's no plus a number, there's no minus a number. Vertex is right at the origin. We're going to look at some where it's not at the origin. Okay, like this one. You might guess where it's going to be. It's going to be up 3 units from the origin. Okay, this plus 3 is going to take the V shape and move it. Okay, so we'll talk about that.
Yeah, so where the vertex is, guys, could shift. It could be on the up or down on the y-axis, could be left or right on the x-axis.
All right. So remember when we graphed y equals mx plus b, we made a table,
Yeah.
and we said we're going to pick values like -2, -1, 0, 1, 2. We're going to do the same idea. We're going to make a table, not necessarily using those values.
Yeah, we're gonna find a number first. That's how you're gonna figure out all your other values.
Okay, so we're going to make a table of values. The way you're going to do it is you're going to take what's inside the bars and set it equal to 0. If you're like, well, what do I mean inside the bars? I'll come right back to that step. That's what's inside the bars. That's what's inside the bars. Yep, I'm going to go right back.
Right back to
That's what's inside the bars. Okay? So take what's inside the bars, set it equal to 0. That value that you get is going to be one of the values in your table. How many values did we use when we made a table before? 5. Exactly. We're going to do 5 again. We're going to make a table with 5 values. Step 1 is going to be the middle value. Okay, so what we'll do is we'll solve this as we go.
Yeah, we'll do an example of that for each step so you can see it happening.
Step 1, set what is inside the bars. Can someone tell me what's inside the bars? Yeah? X minus 2. Set what is inside the bars equal to what? Set it equal to 0. Once I set it equal to 0, what do I do?
Add 2 to both sides.
Yeah, solve it. Specifically, add 2 to both sides. What do you get for x?
X equals 2.
X equals 2.
Is that always gonna be like that? Like the number that's in the parentheses is always gonna be like the positive version of it?
Depends on the problem. Not always, but a lot of times, yes, it will. But not always. So now, once we get that number, we're going to make a table with 5 values. What value is that one going to be out of the 5?
0, 1.
Well, we're going to make 5 of them. Is that going to be the first, second, third, fourth, or fifth one in the table? Middle. Exactly. It's going to be the third
We're
one.
going to talk about those other values in the next step.
Okay, so if we were making a table, which we're going to,
You guys already have the table started on your notes for the next step.
you would put the 2 right there. Okay, the 2 is going to be the middle value.
So guys, on your chart for step 2, right, for step 2, we haven't written in the step yet, but you can go ahead and do what Mr. Hager just did. On the chart for step 2, right, draw your lines to make 5 spaces, and write your 2 in the middle space.
Now, is that enough information to make a graph? What I have written in my table right now?
No, because you don't have a Y.
I don't have any y's and I need some more x's. So what we're going to do to get additional x's, you're going to pick 2 that are smaller. And you can pick anything you want, but let's try to keep it simple. 2 numbers that are smaller than 2. And 2 numbers that are bigger than 2. Fred, can you give me a number smaller than 2?
1.
Okay.
2.
And another one. 0. If you picked -2 and -3, that's fine too. Just try to keep the numbers simple. Don't go too big. Okay, the bigger you make the number, the harder you're going to make it for yourself. Now I need 2 values that are bigger than 2.
Oof, 3.
Could do 3 and 4. Yep, that's perfect.
I want to say 1.
5.
You could do 5 as well. Yep. So now we picked 2 x values that were smaller than this, and we picked 2 x values that were bigger.
So guys, on your notes, right, you have a chart. Actually, I already have the chart down there. You have, so Ms. Ayers is going to take what he just wrote and put it right here.
We're going to write something for 2?
For 2, yep, you're filling in that table.
What about the...
But that's what you just did. Mr. Hager asked you, pick the 2 x values that are smaller. Here they are, 1 and 0. Then you have the 2 that are bigger, 3 and 4. That's your directions for step 2, right there.
But we have to write it down.
I would write it if you can remember it. That's okay, but I would definitely write it.
Here.
Okay, now look at the table. Jack, is that enough information? Did you sign down, Xander?
Oh, I was going to sign up, sorry.
Is that enough information to draw a picture?
Yeah.
It is?
No, we need the
What are we missing?
Y.
Hold on.
Not bad.
What are we missing?
What?
Yeah, we're missing the y's, right? We're missing all of them. So if you have an x value, how do you find a y value?
I don't know. I forget this one.
We've done this before. What do you do if you have an x
Oh,
value?
you plug in for the. Oh, you plug in for the line. Well, you plug in for the x to get the line.
Exactly. If this is your equation, there's your formula to find y. Fill in whatever you have to fill in for x, and then we find y.
How do we know the number that we need to plug in?
They're right there.
Oh.
Those are the numbers you're going to plug in.
Never mind.
So now find all the y values using the formula that was given. Okay, it's off.
That's your step 3 one right in, guys.
So it's off the screen, but that's the formula I'm going to use.
Alright.
If guys, for this one, it just happened to be everything you needed was inside the absolute value. You may get something where you get the absolute value and stuff on the outside. You're plugging in everything, not just for this one, not just what's inside the bars. Everything. Write down everything and solve.
Okay, can somebody remind me, what was the equation we had up above? Y equals,
X minus 2.
and then the bars?
Yeah.
Alright, so now we have 5 calculations we have to do. They're not hard, but you got to plug in each number one at a time.
Hey guys, well, after we do this one, you'll see a little trick, and you won't have to plug in and solve for all 5 different problems or all 5 x values. We'll show you a little trick.
Alright, what's the first number we're going to plug in?
0.
0. What's
-2.
0 minus 2 is negative 2. Absolute value of negative 2.
Scan it.
2.
Scan it.
2.
Scan the ID.
Scan it.
Plus 2? Oh.
2. What's the next number we have to plug in?
1.
1. It's going to be 4. So we have 1 minus 2. What's 1 minus 2?
Negative 1.
Negative 1. What's the absolute value of negative 1? 1. Good. Next one, what do we plug it in?
We're plugging in 2.
Plug it in 2. So I'm going to have 2 minus 2, which is
0.
0. Absolute value of 0. 0. Now let's do the other 2. Watch what happens here. What's the next one we're going to plug in? 3. What's 3 minus 2?
1.
Absolute value of 1?
Negative 1.
No, it's just
So
1.
change it to the opposite.
Okay, let's do 4. And then see if you notice something. What am I going to put inside the bars?
4 minus 4.
4 minus 2. What's 4 minus 2?
2.
2.
Oh my goodness, I see it.
What's the absolute value of 2?
2. It goes 2, 1, 0, 2.
So that's the pattern every time.
Right, you see the same values. It's almost like a mirror image. Okay, if you look at the picture, pretend like you put a mirror right there, and then you flip that blue line over it. Right? It's a mirror image. It's it's a mirror image. Does that make sense, Noah?
But it's not.
But it
Because
is.
it's 1, 2, 3, 4, and then it was 2, 1, 0, 2, 1.
Look at your y values.
Oh, you mean the Y values are
Yep.
here in the okay.
Look at the y values. You started with a 0 in the middle.
Yeah.
You have a 1 on each side of it.
Okay, good.
Then you have a 2 and a 2. That's always going to happen if you set your table up the way we did. Yep.
Now, guys, remember, we're not always going to use, like we told you a couple weeks ago, we're not always going to use these values for x. All right, you're not always going to use these values. It depends on what you get when you set what's inside the absolute value bars to 0 and you solve. That's what it depends on. But this is all, your inside 2 and your outside 2 are always going to be the same number. So what I would suggest is, when you solve, only solve for the first 3, because you'll get these 2 and you'll get that match when you figure out these 2. You have these 2. Don't do any more than you need to. The top one will match to the bottom one, right? The second one will match to the fourth one. They always match up like that. All right, so don't do more work than you need to do.
Now, with what Mr. Roy just said, what is that assuming about your table? Excuse me, about your table.
But it's always gonna have the mirrors for the Y.
They'll be mirror imaged as long as you set it up a certain way.
Oh, so it's saying that if you don't get mirror image, you did something wrong.
If you do that certain table,
What's special about the way we set up this table? 2 is in the middle, and then we picked numbers that were what?
Lower.
How much lower?
Like 1.
Exactly 1 lower, and we picked one that was exactly 1 higher. And then we picked one that was exactly 2 lower, and we picked one that was exactly 2 higher. You have to do it that way to get that mirror image. So if you picked, like let's say you set up your table like this. 0, let's see, what was in the middle, 2? And then you did -1. Well, you did pick a number smaller than 2, and that's fine. But you're not going to get a nice mirror image like we were just talking about. So if you pick a number that's 1 lower than your middle, pick a number that's 1 higher than your middle. If you pick a number that's 3 lower than the middle, pick a number that's 3 higher than the middle. Keep that symmetry.
And guys, if you flipped it and did the higher ones on top and the lower ones on the bottom, that's fine too. As long as the one you pick here is 1 higher and the one you pick here is 1 lower. That's okay.
Okay, now the last thing is graph. Let's make our sketch. Let me try to, actually, let me do a single page, just make it smaller. All right, so I've got the point 0, 2. What's that point going to be called on my V shape? Does anyone remember? Hold off on that. I'll ask you that question in a second. 1, 1. 2, 0. Let me make that bigger so you can see it. Does anybody remember what this point is going to be called?
0, 2.
it's going to be called
That's the actual coordinate.
domain.
So the coordinate is 2, 0, but
The domain. It is the
That's the turn.
vertex.
Change direction.
it's the vertex, yes. So once I have the left side of my V shape, I could go back up and look at the table, but even if I don't remember it, I know that's the other coordinate. It or wouldn't be a mirror image. There's my V shape. Okay, so draw it as 2 rays. Okay. Now they want the domain. What's the domain? What does that have to do with? Which axis? X or Y?
X.
X. How far does this graph go left and right?
Infinity.
Forever. It's never a
Buzz
question.
Lightyear, bro.
Yes. So with an absolute value graph, the answer to domain, how do you write infinity? What do we write, those 3 words?
All real numbers.
All real numbers.
Mr. Isn't the domain always going to be that?
Yeah.
Guys, I don't care what kind of absolute value problem we're giving you the graph. Your domain is always going to be all real numbers every time. Doesn't matter.
Okay, what about,
Yeah, when we do the range, it gets a little bit more tricky.
does this graph go up forever and down forever?
No, it only goes up forever.
It goes up
That's not
forever,
right.
starting from the vertex. So look at the vertex. Where is the vertex? How,
At 2.
well, up and down. It's at 0, and the graph from there goes up, up. So the range here is all numbers from 1 and up.
Up and away.
From 2 and up.
It's infinite.
Wait, you're confusing me.
Infinite upwards.
Look up to down.
Oh, up, yeah. Up.
Does this graph go up forever?
Yes.
Does it go down forever?
No.
No, then it has a lowest point somewhere. What's
Yes,
the
that's
lowest?
2.
0.
I argue we go lower than 2.
0.
No.
There's 2. Do I go below 2?
I said 0.
No, but the 2 that's on the line. The
Up to
other
down.
line.
It's 1.
That's the x-axis.
Oh.
We're talking about the y-axis. I see what you're talking about.
Is it 0?
0 is the lowest. Up to how high?
Infinity.
Oh, 10.
4.
0 to infinity.
Those arrows keep going up.
Yeah.
So the range is from 2, as high as you want to go. So y is greater than or equal to 2, at a minimum 2, but it has to be less than infinity because we can't go higher than that. Or you could write out the whole sentence. The range is all numbers from 2 up to infinity.
This is a quicker way.
That's just a quicker way.
So I would change it please, because I accidentally did something wrong and I put an 8 instead of infinity and that's what it is.
Okay, so look at the original problem for a second. The original problem, it had a minus 2. Look at the graph. How many units did the vertex move from the origin?
And in what direction?
What do you mean?
Well, here's where the vertex is normally, right? Right there.
Oh, well, it moved over like twice.
It moved over 2 units which way?
To the left. No, that's my right. Yeah.
To the right. So this number right here will take your V shape and move it left or right. Whether it moves left or right, it depends on if that's a positive or a negative.
And again, it's when that number is inside the parentheses with it. So we're going to show you some. We're going to show you some that have just the absolute value of x and then a number plus or minus on the outside. But it's when it's on the inside with the x, it's going to move its minus, it moves to the right. What if it was plus? What do you think would happen? If it's minus, it moves to the right. What if it was plus on the inside? Exactly, like Fred said, it'll move to the left. Look at that absolute value. How many units to the left?
3 times.
3 units to the left, right? So it's almost like the opposite of what you think of. You think, okay, when it's positive, I usually go to the right. But for absolute value, it's the opposite. You go left. When it's negative, we usually go left, but for the case of this, we go to the right.
So that number inside controls movement left and right. When we look at a number outside, which I'll do no, we're not going to do this one yet, but what do you, the inside number controls left and right, what do you think the outside number controls?
Up and down.
Up and down. That's going to control up and down. Yep. But let's try, let's see, we just did...
I think that next A is good, Mr. Hager. Should be a good one.
Alright, so what do you think the plus 3 is going to do? Is that left and right or up and down?
Up and down.
Up and down. Now when we did left and right, it was the opposite. Let's see if it's the opposite here. So plus 3, I would like to say, oh, plus, you'd think it would go up 3. Well, let's see if that's what happens. You think it's gonna go up 3? You would think down 3?
No, I don't think it's going to go down.
All right. Yeah, I think you're right. I think it's gonna go up. But let's try it. Okay. Can somebody remind me what is step 1 to do an absolute value graph?
Oh, wait, I got this.
Take the something, set it equal to something. Yep.
Absolute value.
And what's in the absolute value here? Just an x. Okay.
Again, guys, this is what I was talking about before. We have another number there. We don't care about that. We only care about what's inside the absolute value. We do this step.
What do we set that number, or what do we set x equal to? What do we set x equal to?
X is equal to 1.
Oh, yeah.
Set what is inside the absolute value bars equal to 0.
I forgot.
But I thought XO.
This one's a little bit different. So the last one we had 2 things inside the absolute value. Here we only have 1 thing.
Yeah, the zeros kind of tripped me up.
So what do you get when you solve that for x?
You get
0 plus 3 and then 3.
Well, solve this. Yeah,
X equals 0, you can't solve
You
that.
can't, it's already solved. Exactly. So because it's already solved, there's nothing to do. What is that 0 in your table? What value is it?
This way.
We have 5 values in the table. Which one is that?
Oh, the middle one.
It's the middle one.
Oh, yeah.
So make a table. If you don't have one, put the 0 in the middle. Now, we have to pick numbers smaller and bigger, but pick them symmetrically. Okay, so somebody give me a number smaller than 0.
Negative 1.
Negative 4.
No, negative 1 and negative 2. Stop.
No! Let's do negative 1 and negative 4.
But we wanted to look.
We still can.
So we put 1 and 4.
So we put 1 and 4.
Oh.
We picked a value that was 1 smaller, pick a value that's 1 bigger. You picked a value 4 smaller, pick a value 4 bigger. You just have to keep that symmetry, that's all.
Hey guys, you can do it that way, but I would suggest that do 1 smaller, 2 smaller, 1 bigger, 2 bigger. So
Yeah.
you don't bounce all over the place. But Mr. Hager's doing this because he wants to show you that it does work. You can do it this way.
Now plug them in. What's the absolute value of negative 4?
Negative 4 plus 3, that'd be,
Absolute value of negative 4 is
oh, it's 4, so it'd be 7.
7. Yep. Plug in negative 1. What's the absolute value of negative 1? 1 plus 3? 4. Absolute value of 0?
0.
Plus 3?
3.
3. Okay, basic arithmetic, just like we did in the warm-up. 1, what's the absolute value of 1?
So it's gonna be negative.
Absolute value of 1?
It should be
1
yeah.
plus 3.
Yeah.
Yeah, don't get stuck there. It's because you have a positive absolute value, it's going to stay positive. It doesn't flip to a negative. Absolute value is never negative, ever.
I thought you did the answer.
And the last one?
Need something equal.
Absolute value of 4
4,
plus 3.
7.
And look exactly what happened. We got that mirror image again. Okay, if we get that mirror image, we did it right.
Does anyone have a pencil sharpener?
I'll be going in 5 minutes.
You could try that one.
Oh, no, that one ate my pencil last time. I was triggered.
Okay. So graph your points. Negative 4, 7. Whoops, would be up. Okay, double check, make sure I'm okay. I think I'm all right. Negative 1, 4, 0, 3. Okay. Now watch what's going to happen after this point. What is that point called again? 0, 3.
The vertex.
It's the vertex. Because now the graph has turned. And 4, 7.
Oh my goodness, I don't understand how you did that.
Okay. Any question on that one? Now, can someone describe to me, how did that graph move?
What do you mean?
Like from the original, it would have been at the origin.
Oh, it moved up.
Up how many?
3.
Exactly. All this did was take the parent function, which is the basic, and shift it up 3. So important point, stuff inside the bars moves it left and right. Stuff outside the bars, up to down. And did the plus 3 do the opposite of what you were thinking?
Yeah.
Did it?
Yeah.
Sometimes I don't know what I'm thinking. So I don't know.
Like Mr. Roy said here,
The last one, it was a minus.
minus shifted it to the right. You wouldn't think that though, right? Minus on a number line normally goes left. This is the opposite.
No.
Was this the opposite?
Oh yeah,
In the
it went up. No, it's not the opposite.
No, when I think plus up, I think
Yeah.
minus down. So the stuff outside doesn't do the opposite. Okay? You don't have to remember it because you can just make the table every time. But when I look at a problem like this in my head real quick, I say it's going down 1. When I look at this one, I say down 4, left 2. I already know what's happening just by looking at the two numbers. Okay? And if you know that, sometimes you don't even need to make a table. But I would suggest making a table. Let's do
You want to do,
let's do this one.
for that last one, do you want to explain that, how to compare it? Compare it to the parent function?
Compare it?
Yeah.
Okay. Let's compare it.
The last one we just did. This didn't end up, I didn't, we did this domain and range too.
All right, yeah. So let's describe, what's the domain here? How far left and right?
Infinity.
Infinity. So what do you write? All real
Domain
numbers.
is always all real numbers. I don't care what type of problem you have with these. It's always all real numbers.
Are we writing it
Right,
right
Z?
here?
Yep. Okay, range. Does this graph go down forever?
Wait, this domain here.
No. Does this graph go up forever?
Yes.
Yes. So if it doesn't go down forever, then it must have a low point. What's the low point? 3? And it goes from 3 to infinity. It goes up forever. So range, you could say all, this is a lot longer to write, but you can, from 3 to
They call you down.
infinity.
No, they don't.
You get dismissed.
Walk out.
Are we good, Mr. Roy? Is that what you wanted on the one?
Is there
And then they have to compare it to the parent file.
Okay. Okay, I already asked you guys that. You already told me about it. How did this graph move? Just tell me what happened again.
It went up 3.
That's all you have to write.
Yeah, so, and Mr. Hager showed you before, that the parent function, the one that starts on the origin and opens up, when it says compare, that's all he's doing. The graph has been shifted 3 units up.
Okay, so when you describe the transformation, you have to say 2 things. What direction did it move? How much did it move? Don't just say it went up. If you went up, I'll give you half, because you knew which way, but you didn't say how much.
So when we ask you to compare the guys, you're comparing it to that parent function that we showed you at the beginning. The one with the V right in the middle of the graph. I thought you wanted to do 2 more graphs. Yeah, well, technically, can we do this one first? Let's do the other one.
Wait, is that
Find him.
Okay,
So,
so
go please. Goodbye. Have a nice day.
Salt.
okay, this problem, what is this 3 having to do with? Left and right or up and down?
Up and down.
No, inside.
Oh, inside, that goes this way.
Inside, left and right. What about the +1?
What? That goes up and down.
That's going to have something to do with up and down. The -2 in the front of all this?
Wait, so
what
the
is that?
inside, so the inside is up and down.
Wait, would you
Inside is
inside is
left and right.
horizontal.
Yep.
Would you
The outside
distribute the
maybe is up
negative
and
2?
Nope, we're going to leave the -2 right there. So,
What's on the outside? Up and down?
yep. So when you draw a V shape, okay, these can be less narrow, or they can be extremely narrow. What the number on the outside does is that controls how narrow or wide the V is. Okay? Again, do you have to exactly know what's happening? No, we're just going to make a table and figure it out. What you do have to know is what this number does and what that number does.
Then what does the 2 do though?
That controls the width of the V.
How does it do it?
Well, let's make a table and see. Okay?
Guys, for the sake of your notes you have now, this is example 1C.
Okay.
You're writing this in the 1C spot.
I would say. Oh yeah, I do.
Or the middle example on the back side of your notes. The middle example.
Okay, can somebody tell me how do I get the middle value for x in my table? What should I start with?
The inside 3.
The inside
The bar.
the bars. Take what's inside the bars. Good. And do what with it?
Sorry, forgetting all of you.
Look
Plug
at your
in.
notes. You need to.
Step 1. Take what's in the bars and
Put it to 0.
put it equal to 0. And now solve. Okay. If you solve that, what does x equal? 3. So what value is that in my table? The middle one, yeah. Give me a value smaller than 3.
2,
Smaller than 2?
1.
Yep. Now give me values bigger than 3.
4 and 5.
4, 5. What are we going to do with each of those numbers?
You're gonna wait. What do you mean? We're gonna plug them in to find the y.
Yep, we're going to plug them in. The first one, let's go through the whole thing.
Okay, so we would do.
So we have -2, absolute value, 1 minus 3, plus 1. Always start with what's inside the bars. Okay. What's 1 minus 3?
-2.
-2. So we're going to get -2.
Whoa, is it always gonna be the number that's on the outside?
No,
Okay.
just a coincidence. Because when we do the next one, it won't be. What's -2? Well, actually, first, what's the absolute value of -2?
2.
2 times -2.
-4.
-4.
Plus 1 is -3.
-3.
Yeah.
Remember, we had, between what Mr. Hager had here, is -2. What was written here, there was no sign or anything in between, but we have to know what numbers are side by side like that, like a 2 with an X next to it, that means 2 times X. Alright? Same thing here, no sign in between, that means we have to multiply. That's how we got that -4. Remember, anything inside the absolute values, anything inside the absolute value, always comes out as positive. Always, always, always. Forget what I just said. Anything inside the absolute value,
It's always, always.
always, always what?
I don't remember.
Positive, pay attention.
Okay, the next number that I'm going to plug in is 2. Let's plug it in. -2 times 2 minus 3 plus 1. Okay, start inside the bars. 2 minus 3 is how much?
-1.
-1. What's the absolute value of -1?
1.
1? What's 1 times -2?
-2.
-2 plus 1.
-3. No.
-1.
-1.
Grandpa, I didn't ask for help.
Now, really, we only have one more value to find, right? As long as you found the first 2 right, then the last 2 should be right. If you made a mistake finding the first 2, and you copy those numbers for the last 2, then what happens? Then you get more wrong. Okay? Let's plug in 3. What's 3 minus 3? 0. Absolute value of 0?
0.
0 times -2. Still 0 plus 1.
1.
1.
1.
Now, I know we did the first 2 right, so I'm going to copy those values down. Again, if you got them wrong, then now you just got the last ones wrong too. Now what do we have to do? Last step. Graph. So this -3, you're going to see the vertex shifted 3 units to the right. The +1, you're going to see it go up 1. And
Then
that,
how do we shrink it? That's my question. How do we shrink it to? Like, I don't understand. Do we take 1?
don't worry, you don't have to know how to shrink it.
Then how do we shrink it?
You just make the table. That's all you have to do. All you have to know is what this number does and what that number. Don't be too concerned with the -2, but I will give you a hint at what's going to happen here. When you put a negative in front of something, it causes it to flip. So by looking at...
so the 2, no, but I didn't want it to go down.
Yeah, it's going to go down this time. So it's not going to look like a V shape opening up. A negative,
It's gonna look like an arrow.
it's going to look more like that. Yep.
It's gonna look like a mountain top.
Yep, exactly.
It's gonna open down instead of up this time. Or an arrow.
Okay, so we've got the point 1, -3. If you just graph that 1 point, you wouldn't know. You got to graph some more points to see. 2, -1. 2, -1. The next one, 3, 1. Somebody read off the next point to me so I don't have to scroll back up.
What did you leave off with?
4,
4 -1.
-1. All right, got it.
Yeah.
And 5,
-3.
Negative.
-3.
Good job.
Look at it right there. Connect your dots.
Okay, they don't have to go to a nurse because I like this.
All right, so now, domain.
All real numbers.
All real numbers. This graph goes left and right forever. All real
Why
numbers.
don't you have the question we have above domain?
Yeah, it says how does...
Just describe it.
We'll describe it after, sure. Range. Does this graph go up forever?
Range.
It goes down.
down forever. But it does it go up forever?
No.
No, then it has a value that it starts from and goes down from there.
Stops right
So
there.
it would be all in the negatives, which is kind of annoying.
What's the highest that this graph ever goes?
On the y-axis, not on the x.
2.
Goes up 1.
1 and down. You're going to hit all the y values from there down.
Okay.
From 1 and down. Okay, so if you want to write it out the long way, range, all real numbers, yes,
You can use like inequality signs if you want.
but I'm not sure if that confuses people.
It kind of does, just a little bit.
So all real numbers between -1 and infinity. You could also say all real numbers less than -1. There's different ways to write it. In fact, I would probably write it that way. All real numbers less than -1.
I really want to make this problem.
Okay. Now, as far as compare, bless you, don't worry about the compare on this one, because I told you guys, you don't have to know what this number does. You do have to know what this and that do. And that's what we'll finish up with on the one above it. So you want to just do a compare on that, Mr. Roy?
Maybe for that next one, Mr. Hager, just have them describe the transformation.
Yeah, don't do the whole table and everything?
Yeah.
Okay.
Well, if they want to do the table, they can too.
All right, can you guys describe the transformation
Come
here?
on, I keep messing up.
Wait, which number is this one?
This is gonna be example 2.
Okay.
Just use that 3 to a 2, Mr. Hager, on the top.
All right, so
So the bottom, the last one on the page, the bottom one.
Toothpaste.
What? What did you just do? I'm confused.
so I'm about to describe.
So guys, what Mr. Hager's gonna do here, guys, is he's not going to graph the whole thing. What it's gonna show you, because we may just ask you this to describe the transformation. What that means is describe what? Is it going up? Is it going up and to the right? Down and to the right? Left and to the whatever's happening from the original to what's written there in that problem. We're just asking you to describe that to us. So you might be able to just look at the signs there and explain what happens.
And I don't know if you guys noticed on that last one, but that V shape, it got skinnier. If you look at the V shape that we had,
Oh, now I get what you mean by we won't have to pay attention to that, because once we dot the numbers, it'll get skinnier.
yeah.
Why would it
Does
get?
everybody see how that one is a little wider
Yeah.
than the last one we did? It got skinnier.
Okay, now I understand.
You're not going to have to describe if something gets wider or skinnier. All you have to describe is did it move up, down, left, right. So, here, g of x, you can start with this, has been shifted. Now you have to describe. Inside the bars, what does that control? Left and right, or up and down? Inside the bars.
It goes.
So when we did this one, which was outside the bars went up. When we did one that was inside the bars, no,
So guys, outside is going to control up or down. If you have a number on the outside, that's going to control whether it
Side to
shifts up or
side,
down.
left to-
Yeah.
yeah.
So remember,
Inside-
inside we had a -2. -2 shifted it 2 to the right. So inside is left and right. So this number +2 is going to move it which way?
Left.
Or it could move it
It goes like this.
left, or what are my other options?
Right.
Left or right. So now we have to figure out left or right.
Now this is the opposite idea.
Which way, Phil? Which way do you think? Which way do you think this graph is going to shift with the +2?
No, no.
No, inside the bars is left and right.
Oh, right. No, that.
It's going to be left. Okay?
Because it mixes it up.
Right.
Opposite. When it's inside, it's opposite.
So 2 units left. But that's not it. It's moved 2 units left, and what other number is moving this graph? Yep,
-4.
the -4. What's the -4 gonna do? What,
Like, is it like this way?
which way is that?
Up and down?
Up and down, exactly. Minus is gonna move it which way? Down. Down how many?
4.
Perfect.
Just give me your
There's your
So
description.
there, guys, you don't have to worry about describing the domain and range, but it's asking you to describe. So, what controls, someone raise their hand. What controls left and right? Someone tell me.
Left and right is 2.
Someone tell me by raising their hand. What controls left and right? Inside.
The inside.
The inside number, right? So the inside number controls whether it's left or right. Now,
What's inside here, Josiah?
The x minus a.
Yes. Left and right, controlled by A.
so if it's on the inside, right? If the number is negative x, if the number is negative on the inside, what's going to happen to your graph? Which way is it going to shift? If it's negative on the inside x, what direction is it going to go? Right, right? So if it's negative, it goes right. So Nathan, what if it's positive? Goes left, right? Good. Remember, it's the opposite of what you think.
That might be handy to write
I
down.
might want to write this down. Now, up and down is controlled by the outside, right?
Yeah.
There's no opposite rule here for the up and down, right? Controlled by the number on the outside.
What's on the outside here?
What's on the outside of the problem Mr. Hager wrote down?
B.
The B, right?
Whatever B. B.
We're just saying that. We're just saying that this is a number. That's all. So what if B, Joe? What if B is positive? What's that? What's going to happen? Remember, don't think opposite here. Up, right? It's gonna. It'll go up. If it's negative, Sophia, what's going to happen? The number on the outside is negative. What's going to happen?
Oh, never mind.
If it's positive, it goes up. What if it's negative?
Goes down.
Goes down.
I'm very used to you, dude.
So again, that's what we won't make you like identify like the domain and range. Let me go back one, Mr. Hager. We won't make you identify like the domain and range of one like this. We won't make you do that. We're only going to make you identify the domain and range of something like that, or something like the first example we did. If I can get there. Like the first example we did. Nothing, we won't make you do anything like that involves like 2 numbers. Like a number on the inside and a number on the outside. We'll never make you do that. Alright?
So can you guys tell us, we didn't do this one, but which way would this graph move?
What's going to happen? Sometime by raising their hand, what's going to happen here?
Up, down, left, or right?
Based on the original,
It's not good.
what direction will that graph shift?
Well, it's going to move, Fred, because there's a number.
Yeah.
Yeah.
That's bad.
Valerie?
Move down one.
It's going to move down one, right? It's going to shift. Remember, we're basing this all on, I know it's not perfect. Remember, that's the original function. This is y equals, that's what that is. Every time we ask you to compare it, we're always going to compare it to this, to that graph. Right? Always. And we may just ask you to describe the transformation. All that means is say, okay, the graph shifts 2 units to the right and 1 unit down. But if we ask you to identify the domain and range, what's the domain? Someone tell me by raising their hand. What's the domain always going to be when we're doing these? All real numbers. So when we ask you to identify the domain and range, it's always all real numbers. Alright? When we ask you to identify the range, you have to do a little bit more work. You're gonna have to look at how high or low, right, your graph goes. Alright?
So a couple of reminders. Okay, homework tonight will be a worksheet, like always. Test is going to be on Thursday this week.
Tis the season.
It is the season for testing. Wednesday, we're going to do a MCAS question.
Yeah, we'll have some time to review as well.
Probably take about 50 minutes, I'm guessing. We gotta grade it, go over it, and also you guys need your Chromebooks on Wednesday.
No, it's not.
You need your
You
Chromebooks.
guys are scaring me.